Hi guys, today we're gonna look at some AP exam pre-response questions about absolute maximum and minimum. Let's get started with our first question 5 from 2014 AP exam. We're just gonna look at A, find x-coordinate of each relative minimum of f on the interval -2, 3. Justify your answers. So if we're looking for a relative minimum, we basically want f prime of x change sign from negative to positive, right? So this is what we're looking for. So when I check my f prime right here, I only see at this point it changes from negative to positive. So this is x equals 1 point. So we just say that f of x has a relative minimum at x equals 1 since f prime of x changes sign from negative to positive at x equals 1. Okay, that would be the only answer that you would give here. Oh, before I forget, you might express the interval here, and you will say that at x equals 1 on -2, 3 interval, since it changes sign from negative to positive. Our next question is question 4 from 2011 exam. In this question, we'll determine the x-coordinate of the point at which g has an absolute maximum on the interval -4, 3, and we'll justify our answer. So first of all, we need to understand absolute maximum might happen at critical points or endpoints, right? We'll put our candidates in a candidate test and then figure out which one gives us an absolute maximum. So before we continue, let's figure out g prime of x. Remember from second fundamental theorem of calculus, this will be placed in it when you take the derivative of that. So it'll be f of x, right? So now let's look at the critical points. Critical points will be where your g prime equals 0 or undefined. Let's figure out then when g prime of x will be equal to 0. G prime of x will be equal to 0 when f of x equals to -2, right? So let's come over here and see where f of x will be -2 value. So right here at this point, f of x will be -2. So this is a critical point for our function. You can evaluate this by using similar triangles, but they're pretty proportional. You can see this is going to be the midpoint of 2 and 3, so it'll be just 5/2. So g of x has a critical point at x equals 5/2. So now I know my candidates to be an absolute maximum. So I'm going to say g of x. Those are the endpoints, -4 and 3, and my critical point 5/2. Okay, let's go ahead and find the function values at those points, and then we can understand which one is going to be our absolute maximum. First of all, I am going to start with g of -4. Okay. G of -4 is going to be 2 times -4 plus 0 to -4 f of t dt. Remember, to evaluate a definite integral using the graph of the function is just finding the area between the curve and the x-axis. So to be able to find this, I just need to check the area between 0 and -4. So right here, this one, and this one here. So this is going to be pi/4 and then this is going to be 9 pi over 4. However, this is going to be a negative pi over 4 since it is below x-axis. So in total, we have 2 pi here, which is 8 pi over 4, right? Just understand that this integral is going from 0 to negative 4. First of all, I am just going to convert it to negative 4 to 0. And now I know negative 4 to 0 is just going to be value 2 pi, right? So that's why I have here negative 8 minus 2 pi when I use the properties of integral. So the next one, g of 5 over 2. Let's look at g of 5 over 2. So this is going to be 2 times 5 over 2 plus 0 to 5 over 2 f of t dt. So let's look at 0 to 5 over 2 right here. So you can see that this area and the area here will cancel each other, but you can just figure out the areas of these triangles. So it's going to be 1.5 times 3 divided by 2, 9 over 4. And then right here, this one is going to be, you have 1 times 2 divided by 2 is 1, but which is a negative 1 under the curve. So that'll be just 5 plus 9 over 4 minus 1 will give you 35 over 4. Okay? Let's go ahead and write them down here. We have negative 8, negative 2 pi. We have 35 over 4. And finally, we're going to evaluate the value for 3. Let me do it here. So g of 3 is going to be 2 times 3 plus 0 to 3 f of t dt. So you guys come over here, 0 to 3. You'll see these areas are symmetrical. One positive, one negative, so they'll cancel each other. So the value of this integral will be just 0. 6 plus 0 is just going to be 6. And as you can see here, this is the absolute maximum value of our function. But you can just put this in a sentence and saying that g has an absolute maximum value at x equals 5 over 2 by the candidate's test. Okay? That will be find the absolute minimum value of g on the closed interval negative 5, 4. Justify your answer. So one more time, absolute minimum or maximum value can just happen at critical points or endpoints, right? So I need to figure out my critical point here. I already know the endpoints. But before identifying your critical point, remember one more time. So absolute minimum will happen if it is at a critical point. Will happen at a critical point where your function derivative or the derivative of your function goes from negative to positive, right? So as you can see, this is the derivative function for g, because I know g prime of x is going to be f of x right here from this function. Remember one more time, this is FTC number 2. If you are struggling with this, just go ahead and review FTC part 2. So this is g prime graph, right? This is g prime graph. I'm just going to check where it is going from negative to positive. So below x-axis to above x-axis at this point. So this is negative 4. This is the only point that g prime goes from negative to positive, which means this is a candidate as a critical point to be an absolute minimum. Then I'm just going to go ahead and create my chart x and g of x. So my candidates are negative 5, negative 4, and finally 4, which is my endpoint. So let's go ahead and figure out g of negative 5. Okay, so this is going to be negative 3 to negative 5 f of t dt. One more time, I like to use the properties here and just switch upper and lower boundaries to make them in an order. So f of t dt. Let's go ahead and find the value of this. So -5 to -3, as you can see here, it is very symmetrical, positive and negative areas. So it's just a 0. The value of this is going to be a 0. Let's go ahead and figure out g of -4. So it'll be -3 to -4 f of t dt. With the same logic, I'm going to do -4 to -3 f of t dt. Let's go ahead and find the value of this. So -4 to -3 is right here. So it's going to be 2 times 1 divided by 2 is just 1, and -1 right here. So let's go ahead and find the last one, g of 4. So it's going to be -3 to 4. So boundaries are perfectly ordered, so I don't have to apply any property. -3 to -4 right here. So let's get started here. I can find the area of this trapezoid first. This is going to be 1 plus 2 times height, which is 3 divided by 2. So this is 9/2. I have a positive 9/2. Let's go ahead and find the areas right here. So understand that this is going to be the rectangle minus a semicircle here will give me this remaining areas, right? So I just need to say that the rectangle 1 times 2 here minus the area of the semicircle with the radius 1 pi/2, right? So I'm going to write plus 2 minus pi/2. And finally, you can see this positive and negative areas are symmetrical, will cancel each other. So I do have here 13/2 minus pi/2. So 13/2 minus pi/2. So we're looking for an absolute minimum. You guys can see that this is the absolute minimum, which is -1. 6.5 minus pi/2 should be greater than -1. It's a positive number already. Okay. So again, you can just say that the function g, the absolute minimum value of g is -1 on the closed interval, -5, 4 by the candidate's test will be your final answer. Okay. Make sure that you write this down. Let's move on to our last question. Question 3 from 2009 exam. Find the maximum profit that Mighty could earn on the sale of one cable. Justify your answer. You can see $120 per meter, the money earned, and then you'll see 6√x dollars per meter, the money that you spent to produce it, right? So when you're looking for your profit, you should understand that this is going to be 120 minus 6√x dollars per meter, which is your net rate here. If you're looking for the profit function, it should be the difference between the price and the cost, right? So first of all, before you do this question D, most probably you're going to solve question C and write an expression involving an integral that represents Mighty's profit on the sale of a cable that is k meters long. So you're going to figure out this expression 0 to k, 120 minus 6√x dx as your profit function P of k here, okay? So this is what you're going to find in question C, your profit function. And then you'll figure out in question D the maximum profit possible here. For a maximum profit, I need the derivative of your profit function to be equal to 0 to figure out the critical point, because as you can see, there's no endpoints here. So the only possible maximum profit should be happening at your critical point. So what I do is just take the derivative of my profit function. Remember FTC part 2 again. And when you take the derivative of this, kind of cancels out integral here. So it's going to be 120 minus, and this variable is going over here. So 6 root k. So I need to check where this is equal to 0. And then you'll see 120 equals 6 root k. So 20 equals root k. So you understand k is going to be 400, which is your critical point. Let's place this critical point in a first derivative test. So right here, 400 x, p prime of x, sorry. So if you choose a number less than 400, just understand the value of this expression will be less than 120, makes this all positive. So if you choose a number greater than 400, vice versa, the expression will be greater than 120, will result in negative number, right? Just understand it's from increasing to decreasing, while making a maximum at this point. So you understand the maximum profit will be happening at k equals 400 point. But the question is asking us the maximum profit. So basically we need to find the function value at 400. So we just go ahead and place this 400 in function p, 0 to 400, 120 minus 6 root x dx. Okay, let's go ahead and evaluate this. You guys can separate 120 dx and 0 to 400. We'll place 400 in our function p. So p of 400 is going to be 0 to 400, 120 minus 6 root x dx. Let's find the antiderivative of this. So it's going to be 120x minus, I'm going to do this right here for you. So in 6 root x, you guys can just move 6 outside and think about root x only. So this is like x to the 1/2 dx. Increase this by 1. So it'll be x to the 3/2. And divide it by 3/2, which means flip it 2/3. You still have a 6 here. And then this is going to be 4x to the 3/2. Okay, let's come over here for x to the 3/2. So we have 0 to 400. So let's do that. 120 times 400 minus 4 times 400 to the 3/2. Just understand this is like 20 squared to the 3/2. Cancel 8,000. So it's going to be 32,000 here. And then 48,000 here. So the result will be 16,000 for p of 400. So basically the maximum profit that Mighty could earn here will be $16,000. We don't forget the units. Okay, thanks for watching. If you have a question, please write below as a comment. I'll try my best to address them. Bye.